All right. Hello, everyone, and welcome to Alumni College 2021 Warming Signs. I'm Amy Hesse, class of 2003 and Assistant Director of Alumni Engagement. I'm not going to spend too much time on housekeeping. Some of you have already heard this spiel. I'm going to say it again because for some people, this may be their first talk that they've attended Alumni College. So I'm going to go over this information. We learned a few things over the past year and a half about hosting virtual events. With large groups like this, it's best to take audience questions and comments through the chat in Zoom. So Olga's here to moderate the chat and organize your questions for our dedicated Q&A portion of today's session. So feel free to submit them as they come up. And don't worry, we're going to capture them all. We're going to address them later in the presentation. So for those of you who are really wanting to have that quintessential reedy discussion, like a Hume conference that's not limited to the chat, we have a plan for that. So I'll talk about that after this session. So you can join us later today for something that's a little more freeform. Additionally, if at any point during the event you run into technical problems, please reach out to Olga. We'll be recording this program so we can share this material afterwards with alumni who weren't able to attend. So if you'd prefer not to be a guest star in this show and you don't want to be on camera, now's the time to turn your camera off. And we've done a lot of practicing and we have a tech team behind us, but our technology is not perfect. I think we all know that. If Zoom fails at any point, just try to log back in. If that doesn't work, we'll send instructions through the Socio app, our event platform. You can also email Olga, as she mentions in the chat. So now onto the program that you've been waiting for. Today's Alumni College session, Forests and Wildfires, will run for about 90 minutes. Our speakers will talk for about 45 minutes total, and then we'll have about 45 minutes for Q&A. So let's get started. It's my honor to introduce Erin Belval, class of 2008, and Daniel Mathews, class of 1970. Erin is a research forester with the USDA Forest Service Rocky Mountain Research Station. She applies operation research methods to provide research products, decision support tools, innovative frameworks, and answers to policy questions using state-of-the-art, empirically driven models and analyses. She specializes in the management of wildland fire, particularly focusing on the effectiveness and the efficiency of the current management system and policies. She holds a doctorate in forestry and a Master of Engineering from Colorado State University and a bachelor's degree in physics from Reed. Daniel is the author of Trees in Trouble, Natural History of the Pacific Northwest Mountains, Rocky Mountain National History, and America from the Air. His career grew out of his love for the Northwest's trees, mountains, and backpacking, as well as for the written word. He's watched for fires from Desolation Peak Lookout and lived 4 years in a forest cabin without electricity, heating with firewood, and writing by kerosene lamp. So now I'm going to turn it over to Dan. Thank you.
Thanks, Amy. Thank you all for your attention. Welcome. I thought about who my audience would be today, and I figured that nearly all of you probably have lived in Portland for at least a few years, and quite a few of you probably have lived elsewhere for many years since living in Portland. So it may be that when you heard that we had these huge fires in Western Oregon, and we had probably the worst polluted air in the world of any large city for a few days running. You may have wondered, what is going on? I didn't think that that happened in those green, verdant forests of Western Oregon. So, so my plan today is mainly to explain the answers to that question. What happened? So let's see. Oop. Excuse me. Share screen. So these are my books, the recent paperback issues. So what did happen? From a GOES satellite, it looked kind of like this, a huge amount of fire and smoke all at once. It's kind of crazy when you think about it, that there was this much. And this isn't even how bad it got. This was September 8th. And some of the fires that got huge are still pretty small in this image. Like the one closest in the southeast of Portland is the Riverside Fire, which still looks small in this picture. And the one way down at the bottom near the NOAA logo is the Creek Fire in California, which grew to become California's largest single fire in recorded history. And then that big clump of fires just a little below the center of the picture in California is the August complex, which they mostly talk about as the biggest California fire in recorded history. But that's with the help of a lot of fires growing together, a lot of fires with separate lightning ignitions. And some of them didn't even grow together. They were just lumped together by management. So they call it the August Fire Complex because they were managing it as if it were one fire. But that's why, in a sense, the Creek Fire was bigger. Anyway, on September 8th, you see Portland was still in the clear. And I remember going outside and looking to the south and seeing this huge brownish smear off to the south and thinking, oh my God, hope that doesn't hit here soon. And sure enough, it did the next day. I should say, full disclosure, if a human had been looking down from a space shuttle at this scene, the flames of the fires would not have been visible like that. You would have just seen smoke. The flames of fires are not this big. This image actually registers with a camera the infrared radiation as heat coming off of the fires. And then someone at a computer said, let the infrared radiation show up as orange and red. So that's why you have such big patches of orange and red representing the actual heat coming off of the fires. But it's not in the visible light spectrum. Here's a day later. The smoke is a lot thicker. It still hasn't quite topped Portland, but it will very soon. And here's 2 days after that. The smoke is smeared out over a big part of the world, making a beautiful pattern in its way. An ugly pattern, though, to those of us on the ground. Here's the aftermath of the fire alongside the Santiam River in Oregon, the famous melted motel sign. Here's the aftermath of the fire in the next spring. I went looking for morels in the Big Hollow fire. And unfortunately, I was too early, didn't find morels. But you see here that the fire was in this patch, it was very severe in two measures: vegetation mortality severity and soil burn severity. The duff layer, the litter layer, the organic layer of the soil is completely gone. It was probably washed away by rain after the fire turned it to ash, and what's left is just the mineral soil looking like gravel. This is the Opal Creek Valley from a drone. You see that this was high vegetation mortality severity there also. But there were big patches of green left still. And here's the bigger picture, the whole West. Well, too bad you can't see the biggest fires in Colorado because they're behind the images of our faces. But you can see that the bad fire year mostly was in Oregon, California, and Colorado. It was record years within the period of written history since 1850 for both Oregon, California, and Colorado. And I cut out the big Washington State fire from this image because I don't really count it as quite the same thing. It was a grassland and sagebrush fire, which means a whole lot less biomass was burning, which doesn't quite add up to as much fire in my book. So the debate that immediately started, even before the fires had burned out, was, do we blame this on climate change or do we blame it on management? And it was mostly voices related to the timber industry and to republicanism who wanted to blame it on management by the Forest Service. So my view is that there are three explanations here. Those two, one of them partly true, one of them not true. And then a third explanation, which I'll get to third, which I think is the most true. So this graph from a meta study of selected global studies of the question, does climate change increase the risk of wildfires? And as you see here in the graph, 0 of these studies said, no, that's not the case. 2/3 of them said, yes, that is the case. And 1/3 said, well, we didn't definitely find that. We can maybe refine the picture a little bit and inform it. This is a graph of the last 40 years in Western Oregon, the weather, and as of September 10th, looking at the total precipitation and the average maximum temperature since July 15th in each of those years. As you see, the big black dot representing 2020, it was not the hottest year in those terms. It was only third hottest. It was not the driest. It was only third or maybe tied for third driest. But if the ones that were hotter were not drier and the ones that were drier were not hotter. So as a combination of the two, it's right up there among the last 40 years, it's hottest and driest. And what climate change does is, of course, it makes everything warmer and that makes everything drier. So it makes this kind of situation more frequent. So it played a role, it definitely played a role. But what really caused the fire was, well, here's another way of looking at the same thing. The energy release component is how much energy will be released if a certain area of forest happens to burn. 2020 is represented by the red line. The norm over the last 40 years is represented by the black line and the gray areas. And you see that 2020, as of September 9th, goes way outside the bounds of the norm. And then what it combined with, oh, I'm not really ready for that slide yet. What it combined with was wind, a huge, broad scale, strong east wind event. And that's what really made the fires blow up. And it arrived right on Labor Day. Now, we have strong east wind events almost every year in the Northwest. They especially blow through the Columbia Gorge, but they can cross the Cascades as well. And almost always they come in the fall or the early winter. In other words, after the rainy season has started. So what really caused fires to blow up was the fact that the wind event came at the end of an especially hot and dry late summer, and it came before the fall rains started. So that's the case for climate change. Definitely weather caused the fires. Climate tilted the weather field. But what about management? So most of the people who wanted to blame it on management are saying that more logging would have made the forest less dense and less prone to burning. And this is nonsense. I just immediately looked up the areas that burned on Google Maps and saw these were heavily logged areas. You can see all the clear cuts and patch cuts in this area of the fire. And the patch cuts and clear cuts were growing back in plantations, and the plantations are very flammable. They're just as flammable as old growth forest. There's some old growth forest in this area, and it did burn badly, but not worse than the plantations. There have been studies looking into this very specifically, and they find plantations are likely to burn on the whole, if anything, a little bit more intensely than natural old growth forests. Dan Gavin did an immediate, it was kind of an op-ed online piece analyzing this same question. So this is a different fire, the next one to the south, the Holiday Farm fire in the Mackenzie River drainage. The upper part of the image shows the clear cuts just of the last 20 years. They're color-coded according to year. And you see the lower image shows where the fire burned especially intensely. The different colors are for different stages in the growth of the fire. They aren't different intensities, just the intensity of the colors represents the intensity of the fires. So you see it got really intense when it burned into the plantations from clear cuts of the last 20 years. As for the vegetation burn in severity of that same fire, here it is mapped, and this was a very severe fire. I've seen worse. There are some that are almost entirely red, but on the scale of normal fires, this one is way worse than average. And in general, the Oregon Labor Day fires were worse than average because they were in, never mind, I'll get to that later, the type of forest they were in. So then I went to look at some California fires. This was a Labor Day blow-up fire, one of the most intense, the North Complex. And it too burned a lot of it in an area with tons of recent clear cuts and patch cuts. You can see them in several parts of the fire. So more logging would not have helped. Nevertheless, in California, there was a legitimate argument that went on, or debate between some forest ecologists and others who felt that management did play a role. And what they're talking about is not enough logging, but not enough fire, specifically not enough history of low severity fire. The forests were too dense for their own good, too much undergrowth, trees too many, too small, too close together, and this causes them to burn more intensely and more severely than they would have if they'd been in their pre-settlement condition, as it's called, the way forests used to be before the white people arrived. Here's a forest that actually went through the August complex fire last fall. And the fire went through as a low severity fire, just a low ground fire, because the forest had been thinned and burned with prescribed fire. It had been treated the way that they ideally would be in the hopes of restoring pre-settlement conditions and reducing the potential for high severity fire. So you see it can work. And here's just how low these fires can be. This is a prescribed fire going on in Yosemite Valley in the same type of forest. And here's an Oregon version of the same type of forest back in its pre-settlement condition in 1900. The trees are, virtually all the trees in this picture are ponderosa pines. So this is the big difference. This whole theme, which you may have heard in the media about the forests being too dense and therefore more prone to fire, is true, but it's not true across the board about Western forests. It's only true about certain types of Western forests. And the media often miss that point. Most of the time they miss that point. It's true only about forests with a lot of the certain species of trees that are adapted to a fire regime of frequent low severity fire. Ponderosa pine is the one most often mentioned because it's the most extensive. Jeffrey pine is very similar. Giant sequoia, importantly, is another example. Coast redwood is actually an example. Western larch and a few other less common species are also similar in this way. So the whole theme about forests needing to be let fire return to the forest and sometimes some thinning, that's true only of these forest types. It's not true of the Douglas fir hemlock forests of coastal Oregon and Washington. Those forests instead, whoops, one last shot of the ponderosa pine that I wanted to show you. This is in Eastern Oregon, but it's today, and it's similarly a forest which has been restored with thinning and prescribed fire. It doesn't necessarily have to be a grassy understory. It can be bitter brush like here with some grass, but the trees need to be sparse and there need to be not a lot of saplings and tall shrubs. But the Western Oregon forests look like this. So this brings me to my third explanation of why the fires happened. And that is that it's normal. If you looked up what fire ecologists have written about what's understood to be the fire regime of the Douglas fir and hemlock forests. The fire regime, the natural fire regime, is very infrequent, mixed, medium to high severity, large, often simultaneous in 1 year, fires that tended to happen when a strong regional east wind event occurred before the fall rains and at the end of an especially hot, especially dry late summer. Bingo, they predicted it. This is the normal fire regime of these forests. And it comes along at intervals typically greater than a human lifespan. And what you get with natural events that come along at such low intervals is people get oblivious. People tend to assume it doesn't happen here. And this reminds me of the way we felt in 1980. Those of us old enough to remember 1980, Mount St. Helens blew up. And we were thinking, oh, the Cascade volcanoes are active. I didn't know that. We thought they were inactive volcanoes, but no, they're active volcanoes with a typical frequency greater than a human lifespan. So people tended to get oblivious. And I might add the other thing that is characterized by similarly long intervals is those Cascadia subduction zone megathrust earthquakes, which we're still waiting for. So the final question is, the final two questions. First, what's going to happen? Is this going to get more frequent with climate change? The answer there is we don't really know. The odds are that it may happen a little bit sooner. The frequency may get a little worse. It may get a lot worse. It may stay the same, simply because of warming, making the dry summers a little drier. The predictions on precipitation, they lean toward maybe about the same amount of precipitation, but maybe a little bit more of it in the winter, maybe a little bit longer of a long, dry summer. So that would be a little worse together with the heat. And what about the wind events? There have been no studies that I know of about the effect of climate change on frequency of strong east wind events in the Northwest. There's one team that has come out with a couple of papers on this question in California, where they call them Santa Ana winds, especially in Southern California. And this team concluded that the Santa Ana winds were likely to be made less frequent by climate change, at least a tiny bit less frequent. So that's a bit of good news. But on balance, we don't know, and it's more likely to be worsened than improved. Final question, is there anything to be done? Well, the best minds in forest ecology concluded that for this region, no thinning and burning won't help. Prescribed fire won't help. If you make the forests less dense, any improvement in your fire likelihood and fire severity likelihood will last only a very few years, because things will just grow back so thick and so fast. It won't help. What can we do? We have to make the houses, not the trees, less flammable. This is a picture of a neighborhood outside Paradise, California. The neighborhood was almost completely destroyed by the Camp Fire in 2019. But you see a lot of green trees surrounding. The fire was not actually a high severity fire when in this immediate area in the forest. There was just enough fire coming through the trees to set the houses on fire, and then the houses set each other on fire. Houses are more flammable than forests by far, even in California, where density does matter more and can be affected more. Still, the most important thing to do is to make the houses less flammable. And you can look it up online. There are many ways to do this. It'll take some money. Not all of them are terribly expensive, though. Some government subsidies would help, and that's what I recommend doing to prepare for this problem in the future. So with that, I'm going to turn the microphone over to the next speaker, Erin Belval.
Thanks, Dan. That was a really great overview of what happened this past summer, I thought. Hi, everyone. It's great to be here with you. As Amy and Dan have both said, I'm Erin Belval. I work as a research forester at Rocky Mountain Research Station, and my specialty is in looking at how we use wildland fire resources. I may slip up and say that sometimes. When I talk about wildland fire resources, wildland fire suppression resources, I'm talking about wildland fire personnel, so the crews that we use to suppress wildland fires, and also the equipment, so that would be engines, dozers, helicopters, or tankers. But I look at how we use those, and in particular, I take a view of the entire country as a whole. So we thought it would be a nice complement to Dan's presentation for me to introduce you guys to how we manage fires at the national level, what national level managers are thinking about. I'm going to give you a little more context in those 2020 fires, very similar to what Dan showed us, but a little bit different. And then I did want to really quick speak to some adaptions I've seen that I think are really cool. So I'm going to share my screen and we'll get started. All right, let me know if there's any issues with the PowerPoint. So I'm going to speak to wildland fire management across the United States. All right, so a brief history of the fire management system. I'm not going all the way back. I'm going back to the 70s and 80s. And in the 70s, California experienced a burst of simultaneous wildfires on the ground like they hadn't really seen in the recent past. And so they developed this program called Firescope. And this is one of the reports that came out of Firescope. This one's from the Department of Agriculture Forest Service, but Firescope was a joint project between the federal agencies who manage fire and also CAL FIRE, which is the California Fire Management, State Fire Management System. And in this project, they identified a couple of things. One of the things they did that was really interesting and important was they developed the system by which we manage personnel on an individual fire. But I'm not really going to talk about that today. I'm going to talk about the other piece of this project, which was they looked at how agencies were communicating with each other when a fire started in a particular region, and they said this is really inefficient. So the picture on the left, the writing may be a little small, but each of those little circles is an agency or a fire department, and the web of arrows between them shows how all these agencies were trying to coordinate with each other individually. So Ventura County was trying to talk to Los Angeles County and Los Angeles City and the other fire departments and the California Division of Forestry. And then, they were trying to do all this coordination without a centralized coordination point. So in the Firescope project, they developed this concept of a MAC group. And a MAC group is a multi-agency coordinating group. And you can see the figure on the right shows how that works. And the center circle that's labeled OCC, that's your coordination center. And so all the agencies and all the fires, they talk to the coordination center. And then the coordination center talks back to them, and they're able to give out a clear picture because they're telling everybody the same thing. And they can be very clear on, okay, agency A, we need you to send your engine to fire 1. So this is actually a really cool, really important concept for our fire system in the US, because fire doesn't respect jurisdictional boundaries. So we can have multiple fires burning on multiple jurisdictions. So when I say that, we might have fires on Forest Service land, we might have fires on state land. And those fires may be threatening, or likely threatening, different, we call them values at risk, but basically homes and infrastructure, right? Well, we want, as a society, to send the crews and the engines to the fire that needs them the most, that's threatening the most stuff. But of course, if you are the manager on the fire who doesn't get the crew and engine that you requested because the other fire took it, you're not going to be real comfortable with this, even though that we may be protecting better things by sending them to a different fire. So that was challenging prior to this multi-agency coordinating group concept. And what's really another really cool thing about the multi-agency coordinating group concept is that each agency who is invested in the fires in that particular region has one representative on this coordinating group, and all decisions occur by consensus. So if, for example, the Forest Service representative says, I'm really uncomfortable sending all of the Forest Service crews off to a non-Forest Service fire, then the entire group has to revisit that decision. So it's actually, this consensus decision-making and coordination group concept is really powerful. They started by implementing it in California in the 80s, and it's since grown. And in its current form, we have 10 geographic coordinating groups across the United States, and you can see them in the map there. California has 2, because California has a lot of fire. And the way that you get your crews, your engines, if you're on a fire, is you figure out what you need and you tell your local dispatch center. The local dispatch center is functioning on an area, maybe a couple counties wide. It kind of varies, but there's these local dispatch centers. So you tell the local dispatch center, I need a crew. The local dispatch center looks around and sees if there's any crew within the boundaries that would work. If so, great, that crew goes to the fire. If they don't have a crew, then they send that request up to the Geographic Area Coordination Center. If it's really busy, like lots of fire in that region, then the Geographic Area Coordination Center will be hosting a multi-agency coordinating group to make decisions about which fires to prioritize. So the Geographic Area Coordination Center, or the MAC group there, looks around the region, says, do we have a crew to send to this fire? If yes, great, that crew gets sent. If no, then they send the request up to the National Interagency Coordinating Center. The National Interagency Coordinating Center reaches out to the country and says, do we have a crew that could fill this need, hopefully in an efficient way fairly quickly? And if the answer is yes, then the National Coordinating Group says, great, you're going to this geographic area. The geographic area says, wonderful, we're telling the dispatching center, local dispatching center, who then says, hey, incident, you are getting your crew. Sometimes we don't have enough crews. That's when those multi-agency coordinating groups are really important, because if we don't have enough crews at a regional level, crews, engines, any of those suppression resources, if we don't have enough, those multi-agency coordinating groups are making decisions about which fires do we prioritize, which are the most important, who needs these crews and engines and air tankers the most. Same with the National Interagency Coordination Center. They are looking across the United States and they're saying, which region needs these resources the most? So part of the reason that the system is so powerful and actually has worked fairly well in the past is because in the past, we have really seen pretty seasonal fire. The maps you're seeing are large fire activity that occurred in 2016 on the left, 2017 in the middle, and 2018 on the right. And the color of the dot indicates what day of year the most people were out there working on that fire. And what's really important to note is you can see in the Southwest, you get the purple dots. They're down in the Southwest, they're happening pretty early in the fire season. And then as we go through the summer, as we get later into the year, the fire activity moves up into the Rocky Mountains, into the Northwest, and then down around into the later fire season in California. So we don't necessarily have simultaneous fire occurring across the entire US at the same time. And in fact, it's very normal, for example, to see crews from like the Northern Rockies working on fires in the Southwest early in the season, just because there's not fires in the Northern Rockies at that early season, time period. Now, the National Interagency Coordinating Group is the one who really helps coordinate those moves of resources from one region to another. To show you how much sharing there is, this is one example. This is one fire that occurred in Montana in 2017. And on the left, the orange arcs are the incoming assignments. And so this is where all of the people came from to help manage this wildfire or to help put it out. So you had crews, you had managers, you had engines, and so on. You can see they came from all over. So our fire system relies upon sharing resources across the country. And then on the right, the red, you can see what I call the outbound reassignments. I didn't show everybody going home. What I showed was the personnel who moved from that fire to another fire. And you can see, I haven't counted it, but there is a large dispersal of personnel from a single fire out to a whole bunch of other fires. This is a short time period, right? This is a single fire. So we see resource sharing a lot. In terms of the environment in which these multi-agency coordinating groups are operating, here's a little more context. In this graph, I'm showing you large fire activity that occurred simultaneously each day from 2009 to 2019. So each dot is the number of large fires burning on a single day for a specific year. So to give you a sense of what this cloud of graph is what this cloud of dots is, the green line and the green dots, that is 2015. So you can see in 2015, in the middle of the season, we did see over 100 large fires burning simultaneously on the landscape at once. And that cloud of dots, I could connect all of them with lines so we could see all the years, but that actually gets even messier. And this is really just for context. So when we look at what happened in 2020 and what national fire managers were looking at 2020, that's the red dots that I just superimposed. One thing I forgot to say in the last graph, one thing that is really cool about this graph is you can see in April, there's a bump. That bump is the Southwest. And then you can see fire activity, simultaneous fire activity kind of drops off, and then it picks up again. And the second bump midsummer tends to be Rocky Mountain, Great Basin, Northwest, and California. So in 2020, the first part of the fire season, it was a pretty mid-level fire season. Then came August 16th and 17th. And you know how Dan was talking about the wind events, hot, dry, windy? Well, we also got really unlucky because we got hit by lightning storms in California. The map you're looking at is a map of lightning strikes that occurred August 16th and 17th. There were more than 12,000 strikes. You can actually see that the main burst of lightning was in California, particularly Northern California, but that there was some in the Northwest, right? So you guys got some of those strikes too. And it was hot and dry, and I think fairly windy for you guys. And this was the result. Most of these pictures are from fires in California. I think all of them are from fires in California. But after that lightning strike, we saw a ton of fire on the ground. And you can see I've put in another chunk of the 2020 fire season. We went from a mid-level of fires simultaneously burning on the landscape to an enormous amount of fires burning simultaneously on the landscape. And that's a real challenge for people who are looking at what fires do we send these resources to. Oh, and then you can see, I showed the jump in fires for the lightnings event, and then you can see that they're dropping off. We're getting a handle on the fires. The weather is cooperating, so the number of large fires burning simultaneously drops off after that lightning event. And then come the Labor Day fires, right? And again, these are pictures pulled from InciWeb of those Labor Day fires. And you can see I've added in yellow this time another spike in fire activity. So we had tons of fire burning simultaneously on the ground. And not only were there a lot, you can see we didn't reach the same number in 20 as we did in 2015, but also, as Dan noted, a lot of those fires were record-setting fires. They were some of the biggest fires we've seen across the different regions. So it wasn't just a lot of fires, it was also a lot of very, very big fires. So what was happening? What were national managers seeing when they were trying to figure out where resources should go? Where should we send crews? Where should we send the engines? And where did we send them? This is a graph showing the personnel use by geographic area, by region, from mid-September to mid-October. And you can see mid-August to mid-October. You can see mid-August, before the lightning strikes, we had fewer than 10,000 people on assignment. And it was, yeah, a pretty quiet fire year. And then you can see there's a big jump right after August 16th. And that is wildland fire personnel use ramping up as we respond to the lightning fires that was sparked off. And there is a little bit of delay because a lot of times crews, engines, they have to travel. So it takes a day or two after they're assigned to get to their assignments, depending on how close they are. But you can see a major ramp up where we go in less than 2 weeks from 10,000 people on the ground to nearly 30,000 people. And of course, at that point, we were experiencing resource scarcity. So absolutely, we had multi-agency coordinating groups directing where these personnel should go at the national level and at the regional level. And what I really want you to note here is the first bump, the lightning fires. You can see a lot of those personnel landed in California, but you can also see that that yellow, the Northwest, did need additional personnel because there were fires sparked off during that initial lightning event. Then you can see the personnel start to drop because we're starting to get a hit on some of the fires. And then you can see the Labor Day fires. You can see that ramp up again right after September 8th. And you can see a lot of that ramp up is driven by the personnel that are being sent and used in the Northwest. So what happened after that? After the Labor Day fires this year, we saw fire activity drop off. This was a really lucky thing that the weather cooperated because there was a lot of nervousness. The other thing about our national fire system is that a lot of our personnel are seasonal personnel, and they're based on a historical fire season. So come October, end of October, a lot of those personnel are no longer active in the system as personnel we can call on to do firefighting duties. There was a lot of concern seeing that much fire activity this late in the year on the ground, that if the Santa Ana's picked up, if it got dry and hot and windy again, would those fires pick back up, and would we need more firefighting personnel than we usually do in the fall and off season? And the answer was no. The weather cooperated, the number of fires dropped off, and we didn't see any really late season fire activity occur. This is a cool graph showing, so simultaneous fires, real challenge. We definitely saw a lot of that in 2020. This is a graph from a very recent paper that I think is very cool, showing how climate change can affect the probability of us seeing simultaneous fire across the nation that will require, that it will be challenging for suppression resources if we're allocating them in the same way we are now. And what it shows here is that in the 1960s, even midsummer, we had fairly low probability of simultaneous fire across the country. Whereas when we look out 50 years, we're looking at midsummer having really high probabilities of seeing those simultaneous fires. So real quick, I wanted to speak to some of the cool adaptions, because there are some cool adaptions, certainly in terms of resource allocation. There's better and better data tools for managers to look at, but some of the adaptions have to be on the fire line when we're talking about fire suppression. So when there's a fire that we need to suppress, what can we do? One of the cool things is drones are being used more and more and really effectively. So some of the new technology that's coming online is allowing us to manage fires in a way we haven't in the past that does drop some need for personnel. So we need slightly fewer. And drones are one piece of that. Drones are actually being used in a pretty cool manner these days. Another thing that helps us a lot is increased analytics. So these analytics came from some collaborators in my group. This particular set of analytics is designed to help with pre-fire planning. And pre-fire planning can be an enormous help in terms of reducing the number of people we need on fires, because in these pre-fire planning sessions, what they're doing is they're drawing polygons on the landscape. So they say, when a fire starts within this polygon, here's where we think we can stop it. And then if a fire does start, you focus on those places that you think you can stop it, rather than just constantly trying to be right at the edge of the fire, stopping it as absolutely small as possible, especially if it's providing good resource benefit, good ecosystem benefit. It's great if we can let the fire burn out to the edge of the polygon where there's a feature on the landscape that makes it much more likely we're going to be able to catch the fire there. All right, it's been great to talk to you. Thanks for having me. I'm going to turn this back to Amy and Olga, and I think Dan and I would be pleased to take questions now.
Thank you so much, Erin and Daniel. So yeah, some of you have already started to put some questions in the chat bar. That's great. Please keep them coming. I'm going to go ahead and get started on asking some of these questions. So Richard Solarius, class of 1958, says, what is energy release and how is it determined? And I think that some people tried to put some answers in the chat bar, but I would like to hear from one or both of you about what you want to say on that.
Okay, well, actually, the reply that came up in the chat box is terrific. It's totally professional. Someone came up with the definition, so thank you. It was more specific than I could have been, but it's a measure of the condition of the fuel that takes a lot of things into account, the amount of fuel and how dry it is mostly. And it weights small fuels and large fuels differently. It does not reflect wind speed, apparently, but it's kind of a compound measurement of the flammability of the fuels, of all the fuels together in the forest on a particular day at a particular location, but not reflecting the weather.
Thank you. I wondered about that too.
Is that right?
It was a unit of measure I'd never really heard of before. So
yeah.
Jim Kahn asks, in the temperature precipitation chart, is there a recency effect for years that are in the upper left-hand quadrant? So I believe that was from one of your graphs, Dan.
Yeah, I'm sorry, I don't have that at my fingertips. I'm sure if I searched all the papers that I have on file, I could find someone else's graph showing those kind of things, but I don't have it handy.
All right.
But let's see. Yeah.
Well, I don't know if there's a recency effect in that particular chart, but I think research has shown pretty well, and I suspect if you color coded those dots by what year they were, we would see a gradual shift up into that left corner, even if those top 5 dots weren't necessarily the most recent years. There should be a trend there.
Thank you both. Eileen Lovka, I don't know if I'm saying that correctly, class of 2004. What about the role of drought and the role of the pine bark beetle? Here in California, those are both major issues.
Okay, yeah, that is very interesting and complex, and we think that the bark beetle played a substantial role in the intensity and severity of the California fires last year. A group of leading California fire ecologists had written a paper in 2018 that predicted that the sheer mass of all the dead wood from bark beetles in the Sierra Nevada especially could create a class of fire they called mass fire that hadn't really even been seen before. And the creek fire would be the best example probably, and they feel that it kind of bore out their predictions to some degree. It did produce 2 fire tornadoes. It produced pyrocumulonimbus clouds, a plume going up to, I believe, 40,000 feet, which is exceptionally strong plume. It means it was pushing up past the tropopause a little bit. So yeah, that there is a role, and of course the bark beetles. Drought has an effect on the bark beetles in the first place. Both drought and that forest management issue that I tried to talk about. I forgot one part when I was talking about the forest management issue of the forest being too dense and flammable, is that the lack of enough low severity fire over the last 100 years has 3 causes. Usually people tend to think it's all Smokey the Bear, but really the first cause is the elimination of prescribed burning by indigenous people, which happened to different degrees in the different forests of the West, but it is a common theme across a great many of them, and it's a major factor. We decimated the populations of indigenous people, and we moved them to reservations. They were not able to carry on burning as they had been doing and would still like to do and are still doing, I should say. Where they can, they're still doing great work with prescribed fire. And we need more of it. Secondly, the second cause that came even well before Smokey the Bear was grazing, especially sheep grazing, eliminated grasses across broad areas. And the grasses were what was needed to carry the fire within these ponderosa pine forests. And then the Smokey the Bear factor came along pretty much after 1910. It didn't really become policy of the Forest Service. The Forest Service didn't even exist. And then it wasn't policy to put out fires until after 1910. And then they didn't even really get really effective at it until after the Second World War, when suddenly they had a lot of surplus aircraft to put to work fighting fires. So all three of those things contributed to a dearth of the normal amount of fire across these fire-prone landscapes. And more of those fires would have happened at the times of year when they can be beneficial, which are earlier in the year before it gets super hot and dry. And that's when you see more low severity fire naturally occurring. Let's see, the question was the effect of bark beetles. So yeah, bark beetles, there are pretty strong correlations that the epidemic in California happened both because of the severe drought of 2014 through 2017, and because the fires the forests had become too dense thanks to lack of low severity fire. Those factors make the trees drought stressed, and that makes them less able to fight off bark beetles. So terrible mortality.
Yeah, and if I can jump in real quick, what we saw here in Colorado with bark beetle was really interesting. The first 5 years after the bark beetle outbreak, it didn't necessarily increase fire danger right away. So there's a lag in the effect of bark beetle on fire because the trees are still standing there, and even as they're drying out, the experiments that were done by some of the Colorado State researchers were showing that the trees were burning very similarly. The lag is due to as those trees fully die and then fall over. So now they're fuel on the ground, and the fire doesn't have to jump up to get to that fuel. Instead, it can just, the tree's laying down so it can get to that fuel. That's when you really see those effects, and that can be 15 to 20 years after bark beetle outbreaks. The other piece of that is once the trees are down, if you can imagine when a log starts on fire and it smolders for a long time, you release a lot of heat into a single piece of the landscape, into a really small area of soil. So the other thing that bark beetle landscapes with trees down can experience is a higher impact on the soil. So you have more scorching of the soil, which is not an ecosystem effect we particularly want to see.
Thank you both. So we have a question from Richard Slarius, class of 1958. How long does it take to do all the organization of coordinating centers in the midst of a lot of big fires?
They're really good at it. So the coordination centers exist year round. And when it's not busy, there's usually one person designated during the day to be the one who says, yep, we're going to send this crew to this fire. And it's really easy because, well, that's not fair. It's a challenging job, but it's an easier decision because usually you have plenty of crews. So a fire requests a crew, you look for the closest one, you send that crew. So those coordinating centers, they're dispatching centers, they exist year round. Same with the National Interagency Coordinating Center. It's up and running year round. The multi-agency coordinating groups form when fire season gets really busy. And the fire planners, they know it's coming, so they're ready for it. And the system is in place. So everybody knows who the representative is going to be. They're all well aware, well in advance that they're going to need to be able to start attending these meetings, whether or not it's in person or virtual. And so standing up the groups is not a particular logistical challenge at this point.
Thanks, Erin. Eileen Lavka says, looks like the fires also got off to a slower start early in the year. If that's been happening every year, is there any policy discussion about pushing fire season later in the year?
That was just a this year thing that hasn't been happening. And in fact, we've been seeing increased fire activity in the spring, especially we see it a lot here in the Rockies. So yeah, that was a this year thing, not a overall pattern.
Okay. Eugenie Lewis says, are there projections for workforce needs regarding fire mitigation and firefighting?
That's a big question. We're still getting a handle on projections for fire activity. And there are some really brilliant researchers doing really good work to look at, and there's new work coming out that I'm seeing at conferences that like haven't landed in papers yet, right? Really recent work that looks at fire on the landscape. What's it going to look like in the next 10 to 20 years? Then linking that to resource use is an additional layer of complexity. There's not a lot of work that's been done on that. I'm hoping to do some very soon. So
let's see. John Hudson, class of 1952, says, are fire lookout towers less used now than in the 1940s and 1950s? How do you spot fires now? Do you use drones, aircraft? What?
Yes, they use much less, barely, not very much, but go ahead. You probably know more, Elaine. I'm Erin.
Oh, sure. So the lookout towers are starting to fall out of use. And by starting to, I mean, we're not using very many of them anymore. There are, I believe, a couple still in existence, but there are real-time satellites. So I think, Dan, one of the pictures you showed was a graph that used the VIIRS satellite. And that's one, it's updated hourly with new fire ignitions. There are maps for like lightning maps that come in close to real time. So the lookout towers are a thing of the past, and mostly I think it's satellite products that tend to be used.
Thank you. Kellen Stanley asks, I understand that part of why we don't do more prescribed burns is that homeowners dislike the aesthetic impact. Is this a significant reason we don't use this effective tool more often?
It is significant, but it has been notably overcome by citizens of several parts of the West, where they've come around and they're very happy to see the prescribed fire happen. I think especially of Flagstaff, Santa Fe, and Camp Sherman, Oregon. They're burning very close to the homes in Camp Sherman. And people tend to get a little bit freaked out because they see more of the trees dying than they expect, but that's really okay. And of course, you know, there's a legitimate fear. There have been occasional cases of prescribed fires getting out of control and burning a lot of houses. The Los Alamos fire is the big, that's not the name of the fire, but that slips me at the moment. But yeah, Los Alamos quite a few years ago was a really bad case of that. But overall, the record is very good. And also, I should mention the Southeast. In the southeastern US, in the longleaf pine region, they never stopped prescribed burning. I think the white people took over the tradition from the indigenous people, and people take it as completely normal, and hardly anyone questions it.
Yeah, in addition, here in the West, prescribed burning can be tricky politically, not necessarily because of views of neighbors. That is something that is documented, but it is a little bit overstated. But things like you have to get the perfect burning conditions because you have to know you're going to control that burn. There are air quality regulations, so only so many prescribed burns can take place during different times or different days. And then the other piece that is a real challenge for prescribed burning is we have to have the resources to manage them. So if you're going to set a fire, you have to have crews and engines at the edge of it to make sure it doesn't escape. And that's actually been found to be a real barrier to prescribed fire, is you'll have a forest that wants to do a prescribed burn, but it's doing it in the spring or the fall, and the seasonal resources may not be available, and there may not be enough of the non-seasonals to help with that burn.
Tim Rowan asks, what role might slash piles play in the spread of fire, particularly lightning strike fires? There seem to be many, as in hundreds of massive slash piles in large logging areas. 50 years ago, I think these piles were control burned in situ. Now they're just left out to rot. At least driving through Central Oregon, this is the impression one gets.
Yeah, I don't have a perfect answer to that off the top of my head. There are regions where there's still a lot of slash piles. There's regions where they still burn them. There are technology has been developed where you can. So a bunch of forest ecologists came up with this really cool thing. It was a sort of blanket that you put over the slash pile, and then you can burn it without any danger of it escaping, and you end up with a lot of biochar. But it didn't really get off the ground as a commercial entity, unfortunately. So they're working on more ways to dispose of the slash piles in the drier parts of the world, especially the Southwest. They realize it's really not a good idea at all to leave the slash piles because of the fire danger. So they're working on hauling them off or getting rid of them some way.
Thank you. Jim Kahn asks, piggybacking off of Eugenie's question, are there political factors at work regarding use of prisoners to work the fires?
Erin?
So yeah, so I can speak to that a little bit. So it's a very common practice, particularly in California. California fields usually quite a few crews. Those programs, depending on who you're talking to, they tend to be sold as rehabilitation programs. I am not going to get into all the thorny issues associated with the prison crews. Can you repeat the question to make sure I'm answering? Because this is
sure. Yeah. Are there political factors at work regarding use of prisoners to work the fires? I mean, there's always political factors.
Yeah. So there were two things I wanted to say to address that. Number one was that one of the important political factors that comes into play when we're using the prisoners to fight fires is those crews do not participate in a national resource sharing program. They usually cannot leave their state. And again, that's particularly relevant to California because California uses a lot of those crews. The second thing is, yes, there are some interesting political outcomes from relying on those crews. So for example, in California this year, very, very few of those crews went out because of COVID concerns. And so we had fewer of those crews on the landscape, which definitely translated into a change in a change in the resource allocation environment.
Thank you. Actually, I'm going to use that as an opportunity really quickly, Erin, to bring up a thing we thought we might talk about, but we didn't have in the presentation, which is how did the COVID-19 pandemic affect wildfire management in 2020?
So it actually, it had a big impact in the sense that there was a lot of work done on mitigation to figure out how we manage large fires with these large groups of people, because when you're managing a large fire, you can have thousands of people at that fire in close proximity to each other. And we know that there are respiratory diseases that can spread across, we call them fire camps, because every year firefighters complain about, they call it camp crud, but it's your cold, right? So we know colds spread through those conditions. There was a ton of work done by a whole group. It was a large interagency effort to figure out how to manage wildfires while mitigating for COVID spread. And they did things like camp was more dispersed this year. So instead of everybody coming back to a main central point after work was done for the day, people were like camping out closer to the fire line. And there were screening mitigations that were introduced. When we talked to firefighters who were out there on the line, anecdotally, a lot of them just said, yeah, I mean, we just fought the fire. It's just that we had a number of different logistical factors to consider. And there were increased logistics with like these dispersed camps. How do you get meals to people when they're not coming to a central point? But a lot of that did get figured out. It was a huge effort. that I think a lot of people find quite successful, because these mitigations all got in place. They might have not entirely been consistent, but throughout the summer we were learning further information, and as that science was coming out, the managers were trying to base their mitigations, their COVID mitigations, on the science that was emerging. So yes, it absolutely impacted fires, and it was pretty cool to see how the fire management community was able to respond.
And there was no international exchange of firefighters.
Not much, yeah.
Which normally there would be, especially from Australia and New Zealand, because the fire crews down there have winter when we have summer, so they don't have any fires to fight. So they come up here, a lot of them, in a normal year. Even British Columbia didn't seem to have an especially bad fire year in 2020, and probably could have loaned us some would have in normal years loaned us some firefighters at times.
I think the Northwest got a couple crews, but it was not nearly the level that we would normally see. Thank you.
Thank you both for chiming in on that, very unique circumstance that we've experienced over the last year. And then Helen Lessick, class of 1976, says, it was mentioned that homes share fire more easily than trees. How can we decrease building in the forest? So do you want to jump on that, Dan, or do you want me to take that? I have a couple thoughts there.
I don't know. My personal feeling is that it's hard to imagine really. Certainly, you can do a certain amount of trying to cut back on the right to build houses in the forest, but people consider property rights so sacrosanct in this country that it's kind of not a fight I would personally want to take on. And especially when you think about, people talk about doing that in California, and it's hard to, if you say don't let anyone build in a fire-prone area in California, well, where's the non-fire-prone area? I mean, they had a huge fire across Oakland in the 1990s. So it would be really hard to limit the areas, parts of California you don't let people build in if you start going down that path. So I prefer the path of insisting that the building be more fireproof, and that the immediate surroundings of the homes be more fireproof. And you could redesign small towns. There are some great ideas for designing small towns where you make them more compact and you have a buffer area around them. Even like lawn is a good buffer area to put around a town, or if it's got to have a golf course, you could have a golf course circling around a small town. So there are things you could do with urban planning that would mitigate.
I think that's a great answer. I think when you're thinking about zoning, looking at the types of activities Dan is talking about, where you're building with flame-proof or flame-resistant material and insisting on buffer zones around the house, tends to be a lot more effective. You can zone for certain densities, right? But when you get into thinking about zoning for densities, it gets tricky, and you really have to think about what you're trying to achieve. If you're trying to achieve, for example, less flammable houses, well, the thing that's most likely to get a house caught on fire is another house. So in that case, clustered housing is not great, because you have all these houses that can catch each other on fire. But ecologically, we may want those clustered houses because we don't want to break up the rest of the wilderness. So when we're thinking about zoning, it's not just fire that we're zoning for, and you have to think really carefully about what you're trying to achieve. And again, as Dan was saying, there's also only so much you can do, because some of that zoning it's personal property, and that can be tricky here.
Brian Martin says, does the Forest Service have access to systems engineering resources via federally funded research and development center? JPL provides systems engineering for NASA, Lawrence Berkeley provides systems engineering for the Department of Energy, etc.
I don't know the answer to that. And to me, systems engineering is a broad enough term that I'm not entirely sure. We have people who I work with who would consider themselves systems engineers as researchers. But in terms of like contracting out to different companies for specific services, I don't know right now what the Forest Service is using, nor do I know what the larger multi-agency group is doing, because for some efforts like that, you will see a multi-agency effort, but I don't know.
Did you have an answer, Dan? I'm sorry.
No, I don't know anything on that.
Oh, okay. John Hudson, class of 1952, says, how have fire suppression techniques changed in the past 75 years? Is the Pulaski still used?
Yes,
You want to take that? Up to you.
No, you go ahead. I think you're
the Pulaski is still used, and there are still places where digging a fire line, which is where you scrape the earth bare. So when the fire comes up to it, it just hits bare dirt, and that's what stops it. That is absolutely still something that we do. That being said, in terms of, I'm trying to think, last 60 to 70 years, how far back are we going? The use of air tankers has increased since post-World War II. That was a big change. And like I said earlier, we are starting to see drones on fires. So there have been technological advances, technological changes. There's some really cool things we're seeing now with tracking, personnel tracking, so that people have better situational awareness around them. But when it comes to actually stopping the fire, the most effective technology is to make sure the fire doesn't have anything to burn. And so that's still scraping the earth bare. So that would be things like crews do that, dozers do that. Wetting the fuel can help. So engines can do that, especially if they're protecting a road or a particular structure. Air tankers help with that because they can slow the fire spread. So yes, there have been technological changes, but in terms of like how the fire stops, usually it's because we've removed the fuel. Oh, and there's back burning, but they've done that for years too, where they set the fire on purpose to burn into the main fire, so that as the main fire burns out to meet the area they've set the fire in, there's no fuel left because it's already burned, but you controlled the conditions that fuel burned in.
Do you think air tankers are maybe a little bit overused relative to their effectiveness and their cost, because they think that the public wants to see action and it's very conspicuous?
That is so there are places where air tankers can be very effective. There are recent studies that show that air tankers are often used in scenarios that we say we're not prioritizing their use for. So air tankers, it used to be, we would say we would use them on initial attack, where they can be very successful because we're putting them on a small fire. Large air tankers are actually used a lot on large fires rather than initial attack fires. And sometimes in conditions that are not necessarily particularly effective. The reasons for that, I'm not going to speculate.
Allison, I'm not sure if this was intended to be a question, but there was a question in it. So Allison says, I live in one of those Monterey pine forests in California that should never have been developed. We're considered one of the top 3 most at-risk communities in the state. I wonder if Monterey pines also need to be thinned. My understanding is that they do, but our locals keep planting more of them. So, you know, do you have any thoughts on the Monterey pines, either of you?
Sorry, I don't really know where that fits in the low severity fire adapted scale of pines.
Yeah.
And I don't know the Monterey pine ecosystem either, but I will say it's not an unusual problem to have community values, things like wanting to see trees come up against, but we also want to mitigate fire spread. So there are people do actually tend to be amenable once they've been educated about this is increasing fire risk. You will see people amenable to taking those actions. But it's a real challenge.
So another tree type, Richard Solaris says, the Oakland fire was a eucalyptus, an exotic non-timber species the Australians foisted on people. So I don't know if either of you have any thoughts on that, or other kinds of trees that, have just, they shouldn't be there, or they're irresponsibly managed.
Well, he's totally right about the eucalyptus. It is a problem in California, and it's a very flammable tree, and yeah, ecologists don't like them. Be an interesting, I mean, there's something of a debate over the mixed conifer forests of California and Oregon, and how much true fir there should be in them. It's kind of funny, but it's definitely a native tree. It's always been there. In some cases, it's the white fir, and others it's the grand fir, mostly the white fir. And it's not as well adapted to frequent fire. It's more likely to be killed. And it's often a big part of the densification that has happened within mixed conifer forests, an increasing portion of true fir and sometimes Douglas fir relative to ponderosa pine being kind of a problem. I hope that kind of answers the question. I mean, I know that some of the gung-ho enviros who don't think there should be any thinning done ever because that's a form of logging, and they're afraid, they're sensitive that it'll be used as an excuse for bad old commercial logging, which is true. It is sometimes used that way. So they have sometimes argued there's no such thing as the wrong kind of tree. There's nothing wrong with all those true firs being there. And they even do studies trying to establish that there were more of them in the past than you guys think. And then you guys come back and with more studies. And so no, there really weren't very many of them in the past. So it's been kind of an interesting issue to follow, but I would say there do tend to be a few too many true firs in the mixed conifer forests. And there have also been studies in Oregon showing that that in some of the drier mixed conifer forests in Oregon, that the tendency will be that once you get a lot of true firs, you'll get them wiped out by a bark beetle attack.
The other concern, pressing concern right now for invasives in fire tends to be more in the grassland systems. So we are having issues with invasives in grassland because what happens is a fire comes through, it burns off the native grasses, and we have invasive grasses that establish a lot quicker, and they really like that. But the native, they don't provide habitat. And so we're losing like sage-grass habitat. And actually, there was recently a big BLM effort to look at do we put in fuel breaks in these grass systems where you're disturbing the system by putting in a fuel break, but also if you don't, there's still that fire risk. So are you mitigating better by putting in the fuel breaks or not? But yeah, it's a real concern. Invasives in fire is a real concern, particularly in grassland. And I don't hear as many of those concerns in the forested systems. The concerns about fire in the forested systems rather than invasives tend to be if you get a really hot, dry fire or a really severe fire coming through and it kills the trees, do the trees come back, or does that particular ecosystem convert to a meadow type ecosystem? And sometimes the trees just don't come back. And that is climate change affects some of them.
So this is reflecting on something we were discussing earlier, and I want to make sure I say it. So Jim Kahn says, I'm going to push back a bit on the prisoner question. As we have seen in previous sessions in this alumni college, there are social issues that arise whenever solutions to environmental problems are considered. Here, there are equity questions, fair pay, good time, treatment on site that arise if one makes the pretty obvious assumption that convicts are people. I wondered if either of you or both of you have anything to say to that.
I agree, but it's not something I'm very expert on. I mean, I think I'd like to see them paid better. And another effort that I think some of the legislators in California have proposed and maybe even passed, you probably know. Did they pass a law saying that prisoners with the convicts who had experience fighting fires as convicts should be helped to find employment or training as firefighters when they get out, if they want it. That's another approach that could help a little bit.
Yeah, and I'm not sure what they did, but I think I read an article recently about same consideration is happening in Arizona. I'm absolutely not an expert in the use of prison crews. I know that we use them in California, but I am not an expert in how they are managed. I tend to look at a national picture and I don't look very specifically at CAL FIRE. I think there are a lot of good points that are raised. I know anecdotally you can find people who say that their time on the crew was very valuable to them. I suspect you could also anecdotally find people who thought that was not true. I wanted to put that aside simply because some of the equity issues that you bring up are very, very important, but I'm just not an expert in them. And since I can't speak to exactly how those crews are managed, I'm uncomfortable commenting very much on it.
Okay. Piggybacking off of that, and you may have already addressed this, so you don't have to speak to it very much, but Eileen Lavka asks, aside from COVID impacts, do you see the use of prisoners to fight fires increasing over the years, and what policy discussions occur about that among firefighting planners?
Most of the firefighting data I look at goes back to 2007. As far as I'm aware, I'm not sure if there's a large increase in the type 1 crews in California that has occurred over that time period. And I don't know about some of the political discussions. So yeah, I'm gonna leave it at that.
Yeah, thank you. I really appreciate you both speaking to this issue because it is, it's an important one, but I also know that it can be very uncomfortable to speak about something you're not expert in. And perhaps we can at some point find some alum who is, and we can have an alumni discussion about that later on. We have 7 minutes left in this session, so I'm going to try to get to the rest of the questions that we have here. We have 3 of them. So Mark McLean, class of 1970, asks, major electrical transmission lines have vegetation management where anything, including trees that could threaten the lines, is removed. Are these effective fire breaks?
There are real concerns about using underneath transmission lines as fire breaks because you're not always certain if that power is turned off. And that can be dangerous. I know they clear around infrastructure to try and save it when fires occur. I don't know if those particular fuel breaks are being used as fire breaks, just because I know there are those concerns about the lines being live or not. I don't know.
I'm sure they would serve as fire breaks to some extent in some kinds of vegetation, but since their location wasn't planned with that in mind, they're probably not a huge contributor to fire control.
Kellen says she spoke to someone who lived through the Paradise Fire. She owned a horse that she saved by setting up a sprinkler to protect a large enough area in the pasture that the horse could ride out the fire which burned around it. Any other creative solutions to enact during an active fire? I know someone who jumped into a pool.
Yeah. Well, that one, is sprinkler systems are great for saving a house, and they've saved quite a few houses, but they are pretty expensive because you can't count on either the electrical system or the water system having electricity or water available during your fire. So you pretty much have to have a generator running a pump, your own generator running your own pump from your own water source, your own well, or your own pond that you've saved up for this purpose. So it's a pretty big deal, but certainly can be effective.
Eugenie says forests are considered sinks to absorb greenhouse gases. Where does increasing the planting of trees and forests fit into this discussion?
Well, I would like to see more money available for replanting forests. There's pretty decent evidence that if we had more and more, they need more nurseries. I mean, there's a shortage of nursery stock given all the recent fires for Forest Service land. They don't have enough seedlings. So I think that it all depends on local conditions, but in a lot of these fires, having enough seedlings planted at the right time of year in the right year could definitely help return that burn to another forest, as opposed to it converting to non-forest brush field. Aside from that, I don't think increasing the density of forests within most of the West is not the right way to go. So I would say that tree planting should mostly be reserved just for logged areas where they probably already do it on industrial land, and for burns where there's a risk of the forest not returning on its own.
Yeah, it's very ecosystem specific, right? Like Dan said, a lot of forests, we don't want to make them denser, despite the fact that maybe you might capture more carbon with more trees. You might not too, depending on how fast they grow and how that impacts other growth of other trees within that forest. But it's potentially very valuable when we're talking about restoration and prohibiting type conversion.
Thank you. I have a question really quick. So reflecting on almost 4 years ago, when the Eagle Creek fire was started by a bottle rocket that a teenager shot during red flag warning, I'm just curious what both of you think. Well, how many fires are really started just by carelessness, people not putting out their campfires, people shooting fireworks, doing those, or, having chains on the road? Do you see that if there's any possibility of more ticketing or enforcement, would that make a difference? And do you know of any strategies that have worked in terms of bringing out about awareness among the public about being very careful not to start fires?
I can't really answer that specifically.
So
go ahead.
We do have data on number of fires started by people, and you will see where people are concentrated, you have more human starts, you have more starts in general. It is a problem. There are public campaigns that have helped raise awareness. And in fact, Smokey Bear did a very good job of that. Smokey gets blamed a lot of the time, but he did a very nice job of asking people and educating people that, we don't want to say all fire is bad, but really we don't want a fire started by your campfire. That's really important. So yes, good fire occurs, but as you just alluded to, not all human ignition is good fire, and often it's bad fire. So when we see areas get more densely populated, yes, we expect to see that ignition rate go up. And yes, that's correlate. Some of those do turn into large fires. I don't remember the percentage off the top of my head, but we absolutely have the data on that across the United States.
Great.
And since you brought up the Eagle Creek fire, I hated it when it happened and it resulted in so many favorite trails being closed.
Yeah.
But I have visited in the area a few years later, and the recovery is fairly impressive, and I think it is within the long-term historical norm. And I don't think it's a place that's in danger of not reforesting. So I wouldn't place it as clearly a bad fire at this point.
Yeah. Eagle Creek's one of my favorite hikes. So it just broke my heart. Like when the ashes were falling on Portland from that fire, I almost cried. Like it was really heartbreaking. And I know there were people who were almost, attacking this kid and his family for, and it was a miracle that people didn't die or get seriously injured from it. So I think about it because I see people burning fires all the time during a burn ban. And it makes me so angry. And I'm wondering, where are the people enforcing this?
Yeah.
Enforcement can be really, really challenging because it's a really dispersed problem, right?
Yeah. Well, thank you both for answering my personal question. And I think we're going to wrap it up. Thank you so much, Erin and Dan, for sharing your expertise about the impacts of climate change on forests and wildfires and the fire suppression data. I've learned a lot, and I think other people here have as well. And thank you all for your really great questions in the Q&A.